Hello everyone and welcome to another episode of GDDV 106 Development Concepts. My name is Kasanas. Guys, we're moving along pretty well and we're moving into some really interesting stuff. So far, we have covered a bunch, and you know what? This slide is getting too long for me to read every single video, so you know what? We're going to skip it, I think, from now on. Guys, we are moving into the idea of input. We've already talked about the idea of movement, so we understand how things move around the screen. Now let's check out how a player can actually move that stuff themselves. All right, let's get started. So today is all about player input. All right, and there are a number of different things we're going to have to kind of look at before we can really understand input. And when I say input, I'm talking about the methods in which the player is able to interact with the system that we're creating here. And we're going to take a look kind of at three different methods: the keyboard, the mouse, and the console controller. And they're really kind of all very similar in nature, and they all utilize, depending on which system we're using, actually I should start with this, depending on which system we're using, they all are going to utilize something called axes. That's what we're going to study today, axes. And the problem is that Unity has now updated their player input, or their ability for input. There's the classic input system, which is what we're going to kind of take a look at. And then there's the new input system. But the new input system is not directly available immediately upon opening up a brand new scene. Instead, you have to go into the package manager and you have to download and install kind of the new input system. And we haven't talked about that in any way yet. So I think for now, we're going to talk about the classic input system. And if in a later date, once they've kind of integrated everything so that there's no longer a classic input system, then we'll talk about the new input system in Unity. Or maybe we'll even do it at the end of this series. Who knows? But for now, guys, we're going to talk about the classic input system. And the classic input system, as I've already mentioned, utilizes something called axes. And axes really are a number of different variables that Unity has set up for you that can be used to monitor specific keystrokes, or specific button pushes, or joystick movement, all the input methods that are available to you. So these axes are something that Unity set up for you, these default variables that Unity set up for you. You can create your own as well, but there are a number that are already set up for you. If you want to see the axes themselves, you can see them under Edit, Project Settings, Input Manager. And once you open that up, you're going to get a list of axes. When we see these axes, and this is exactly what it's going to look like, when we see these axes, we're going to see what they're actually monitoring. So in the specific example I have here, we have the horizontal axes, and it's got a negative button, left arrow, and it's got a positive button of the right arrow. It also uses as alternative keys an A for the negative and a D, for the positive. So your WASD is what we're looking at there. And this is kind of the typical example. So basically what Unity is saying is, if you utilize the keyword horizontal, and it has to be spelled exactly as you see it here. If you get the spelling wrong, it's not going to work, including capitalization. What it's looking for is it's monitoring the left and right arrow keys as well as the A and D keys for input. And once we have input from those specific keys, it's going to do something for us. Or it's gonna in some way let us know that it's actually been hit. Okay, so in the case of the left arrow or the A key, if either one of these are depressed, it's going to give a value of -1. If the right arrow or the D keys are depressed, then it's going to give us a value of 1. And that value is going to be maintained across the entire time that we are depressing those keys. Whenever the keys are not depressed in any way, that input is going to return a value of 0. And we use very specific code in order to be able to verify that. So we'll talk about the code in just a minute. Here's another example of an axis. And in this particular case, we're talking about Fire 1. So once again, we can see on the left-hand side of this particular screen, we can see that we have ourselves the input manager, and the axis name is Fire 1. No space. So in here where I actually have a space, that would be wrong. That would actually result in a spelling mistake, and it would therefore not actually work. So ignore the fact that I've written Fire 1 with a space in there, and instead take a look at the name in the input manager. It has to match exactly. So the default key, or the positive key, is the left control button, and the alternative key is the mouse button 0. In either case, whenever you're using this, it's going to only generate a positive value. So there is no negative values with this. If the left control is depressed, we will activate a value of 1. It'll return a value of 1. or if the mouse 0 button is pressed, it will give a value of 1. Otherwise, fire 1 again will return a 0. So there'll be no value associated with it, or a 0 value, I should say, associated with it. So that's a mouse example. And lastly, this is a controller example. So this is the Fire 2 example. And you'll note the difference. In this particular case, our positive button says joystick button 1. And what that means is that it's looking for the joystick button number 1. And in this particular case, it's actually getting from any joystick. We didn't specify. If you take a look under join num, we haven't actually specified the fact that we are using a particular joystick. And you might want to do so if you've got yourself a game in which you're creating a multiplayer game where you're sharing one screen, so kind of local. You'll want to specify which joystick you're getting what from for particular characters. If you don't do that, then every time player 1 presses the button, let's say the character is going to jump and all the characters on the screen will jump. So we'll have to make sure that you guys are aware of that as well. There's a few differences here from the other ones as well. There is the gravity and the dead and the sensitivity are all different values than we saw in the previous examples. But otherwise, this works exactly the same. When joystick button number 1 is depressed, we will have a value of 1. And if it's not depressed, it'll return a value of 0. Okay, so that is how the axes themselves work. We can go ahead and we can set this up any way we want. We can add additional ones, but Unity has several that are available to us immediately. Okay, so this data is being generated for us. Now we need to be able to access it. We need to be able to get it and use this data. So let's take a look at how we're going to do that. At the very bottom of this particular slide, you're going to see 2 lines of code. Float move equals input.getAxes, and in brackets and in quotations is the axes we're interested in, horizontal. The second one is float move equals input.getAxesRaw, and again in brackets, in quotations, is the axes we're interested in. Utilizing the getAxes or the getAxesRaw is going to allow us to access the data that's available inside of that axes. And in this particular case, what we're doing is we're storing that value, whatever the value returns to us, inside of move. In both cases, that's what we're doing. Now, the cases themselves are slightly different. Float move equals input.getAxes horizontal. What that is going to do for us is it's going to allow us to monitor the change in value of the button press. That's all it's going to do for us, is monitor the change in value of the button press. We're going to want to put this line of code in our update function, so it's doing it all the time, as quickly as we possibly can. We don't want to miss any of our user input. What this is going to do is it's going to return a value depending on which button is pressed. In this case here, horizontal has a negative and a positive button. If you press the positive button, the getAxes is going to return a value between 0 and 1. So it's going to be greater than 0 and up to and including equal to value of 1. All right, and we're going to have all of the floating point numbers in between. So it's going to give us a range of data. The same thing is true of the negative value. So if we're pushing the negative button, it's going to give us a value less than 0 and up to and including negative 1. And again, it's going to be a range of values. So we're going to have all the floating point numbers in between. If no button is depressed, we're going to have a value of 0. Otherwise, we will have some value greater than 1 or less than 1, depending on what we've pushed. All right, it's a floating point number. Now, let's take a look at the difference between this and getAxesRaw. getAxesRaw works in a very similar manner, except for it only returns whole numbers. All right, getAxesRaw, if you press the positive key, will give a value of 1. If you press the negative key, it'll give you a value of negative 1. And otherwise, it's going to return a value of 0. Now, once again, in this particular case, we are returning a floating point number, and move itself is going to be a floating point number. But it's only going to have a value of negative 1, 0, or 1. And why you would use either of these is really up to you. You're going to, let's say you had it in the case of movement, and you wanted a slow ramp up in speed, or you were really particularly interested in how far the player is pushing that button down, or all the values in between. Then you'd use the getAxes. If you don't care, if all those additional values aren't important to you, and all you really care about is that the player has pressed a button, and I don't care how far they've pressed it, I don't care about anything else, I just care the fact that, yes, they've pressed the button and it's actually active right now, then you're going to use getAxesRaw. Okay, they do really exactly the same thing. Just more information is available to you in getAxes. So how do we go about using this? Well, we've already talked about movement of our assets inside of Unity. We talked about that in the last video. Now, putting these two ideas together is going to allow us to actually go ahead and move our objects around. You can either do it right inside of the update if you want to. I'd like to try and keep my update relatively clean, so I'd recommend possibly creating yourself additional functions for movement. However, if you are monitoring your input inside of your update, and you're collecting that value in move, you could then either use your add force, like we talked about in the last video, by simply applying your move value, multiply it by the maximum speed, and multiply it by your vector. And that's going to move your object in that particular direction with the magnitude that you've assigned it. If you give it a move value of 1, well, it's going to move in the positive direction. And if you give it a negative value for move, well, then obviously it's going to move in the negative direction, right? So this takes care of moving everything in the proper direction as well, if you've got the vector in here, obviously. And the same thing is true of, let's say, a rigid body for velocity. Exactly the same way, we talked about this in the last video, you can use velocity. If you do, creating a vector that's going to be set to your velocity based on the move that you've collected from the input.getAxes or getAxes raw, multiplying it by your max speed, whichever axes you want it to move along, then it's going to move in that direction at that particular velocity. And once again, like I've already mentioned, having a negative move value is going to move it in the negative direction, along whichever axes we're talking about. And if you have a positive, it's going to move in the positive direction. That's how easy it is to collect input from your player and begin moving your objects around the screen. All right, I think that we've discussed it long enough. Let's head over to Unity and take a look at the code behind all of this. Okay guys, here we are inside of Unity, and I am still in my dev concepts, and I am utilizing week 6 scene like we were in the last episode. And there are only a couple of quick changes here, so it's going to look very familiar to you if you followed along with last episode. I still have my 3 zombie heads, my 3 platforms, and the zombie heads still have the movement script applied to them. Each one is moving with a different manner of movement. However, the Kasana's head is slightly different. I'm utilizing an input script instead. Let's see what happens when I hit play. When I hit play, you'll note that still the zombie heads are rolling away by zombie heads, they're rolling away. However, the Kasana's head is just sitting there. It is waiting for input. If I hit the left or right arrow keys, because I'm looking at the horizontal axes, we'll take a look at that in a second. If I hit the left or right arrow keys or the A and D key, my head will move. So there's my head moving, there's my head moving in that direction. You can see that I have complete control over how this head moves. Now, it's taking a little bit to slow down here, and that's because of the particular movement I have associated with it. But you can see that I have complete control over how that head moves. It fell down. Okay, that's cool. Let's stop this because I showed you what I wanted to show you anyway. Let's go over here under the edit. Let's go down here into our project settings. Let's go in here into our input manager, and let's open up our axes. So this is the classic method of doing input. Up here you can see this is where you can change around, configure your controls. All right, but it says here, consider using the new input system in the package instead. So you can go into the package manager right here and download the new one if you want to. But like I said, we're taking a look at the classic one. Okay, what I am looking at here is the horizontal. And like I said, we've already seen this already. We know exactly what this is doing. I've got myself the name horizontal, my negative and positive buttons left and right, my alternative A and D. We have a particular gravity setting, sensitivity, and dead zone. That's based on the button pushes. We are using a key or mouse button. So we know all this kind of stuff based on this. If we wanted to add more, we could by simply changing this value. If I put in here 19, I'm not going to do it. If I put in here 19, it's going to add 1 onto the bottom. And it'll just copy the last one you had. It'll copy that last one. You have to go then and change all of your values. Okay, so that's the input manager. That's where it's located. Now let's take a look at the actual code associated with this movement. All right, let's head on over into Visual Studio. I'm going to click on Kasana's head and double click on the input script. Okay, here we are inside of the code, and I actually have the movement script as well as the input script here. So let's just take a look. There's not a whole lot of difference in these two. In fact, let's take a look at the movement script first. This is the one we took a look at in the last episode. All I'm doing here is I've got a value for my move, how far it can go. I've got 3 different bools to tell me what kind of movement. I go in and I find my rigid body, and lastly, in the update, I simply go through and I apply the appropriate movement. That's what we did in the last episode. The input script is very similar. Let's take a look at it. Again, how far am I moving? I've got a value here. It's public, so I can set that value inside of the inspector afterwards. And I have the 3 different movement types available to me: translation, velocity, and movement. And force. I also have in here a rigid body, which I'm looking for. And lastly, I've got in here a brand new float value. It's a private float variable called move. Now, inside of my start, I have my RB get component rigid body 2D. We talked about this a little tiny bit in the last episode, but I'm going to expand on it right now. My RB equals get component rigid body 2D brackets semicolon. So the get component function, what does this do? This goes in and it looks for a specific asset, in this particular case, a rigid body 2D. It looks for a specific asset, and it's only looking within the hierarchy on the specific hierarchical layer that the script is located on. So in this case, this script, my input script, and my rigid body need to be in the same hierarchy layer. If they're not, it's not going to find anything because it doesn't look anywhere else. However, there are several versions of getComponent. There are getComponent and parent, and getComponent and parent will look in the layers above the object, or above the particular layer that this is in. So, if in my hierarchy I have this getComponent and parent on one, the script itself on one layer, it's going to look at all the layers above it in the hierarchy for whatever it is I'm looking for. In the similar manner, we've got getComponent in children. And guess what? It looks in the child layers, all right? And all the different child layers that are available within the hierarchy for that particular component. Now, we have several other versions of this available as well. We have getComponents in parent, and getComponents in children. All right, the getComponents, regardless of which version you're going to use, is going to go through and it's going to return an array of all the components that you have that particular search requirement. In this particular case, rigid body 2D. We're not going to have more than one. Well, we might in all the children. We probably won't in the same layer. I don't think you can do that. It'll break. But getComponents could be used, for example, if we had a series of colliders and we wanted to collect all the colliders that were on this particular layer. We have several compound colliders and we want to do something to all of them. Maybe we wanted to scale them or whatever we were going to do. We'd use getComponents and search for the colliders and then return an array of colliders and then deal with that array however we wished. All right, that's the difference. So getComponent is super helpful. You're going to use it all the time. All right, getComponent. So make sure you know how to use this. Let's take a look at the real difference, however. This one line of code is the real difference in this particular script. In the update, I am accessing the input.getAxes and I'm watching the horizontal axes. I'm going to be watching every single frame for my player input, and I'm watching the left and right arrow keys as well as the A and D keys. Now, what am I doing? Again, all I'm doing is I'm applying it to one idea, all right, to one of the movement methods. I've changed around this if statement a little bit just to make sure it works. So if it's translation, if that bool is true, and the absolute value of move is greater than 0, that means the player is pressing the button and I want to start to move my object. If I head down to my move translation, it's exactly the same as it was in the last episode. All it's doing is it's applying a transitional move. Looking at it now, because this value is going to be a value of 0 anyway, so I probably didn't have to do anything. I didn't have to do this extra code, but it's there. Just to demonstrate, I guess, the if statement and the mathf.absolute. In the case of velocity, we didn't need it because our move value is going to be 0, and therefore, we are not going to be moving it when we set our velocity. If the move value is 0, whenever we're not pressing the button, well, then our move distance in the x is going to be 0 anyway. It's going to be multiplied by 0, giving us a value of 0 in the x, no movement. The same is true of the add force. With a value of 0, I'm going to add 0 force and in the x, and therefore there will be no movement in that particular direction. You know, looking at this now, I actually probably could have gotten away with it. Transform.position.x plus 0 times distance times dot. Yeah, I could have gotten away with it anyway. I didn't actually have to do anything with this either. This was not required, just because we're not actually going to be applying it. We're not actually changing it. If it has a value of 0, it's not going to do anything anyway. But anyway, guys, this is the only real difference then right here is our input.getAxes, and we're searching our horizontal axes, and we're storing that value in move, and we are multiplying our move value times the move distance in order to calculate how far the object is going to move. That's it. There's nothing else in here at all. That's the entirety of the difference in those two. All right, and that gives us a big difference as far as the movement inside of Unity. Let's go back to Unity and watch it one more time. Okay, here we are inside of Unity, and with our Kasana's head selected, we had force, we had translation available, so if I hit this instead, I'm going to turn off my force, and I hit play, you'll see that my head is moving. I can move my head back and forth, there we go, my head's moving really slowly, and that's based on the move distance. All right, if I stop it, and I set it up so it's using velocity instead, and I hit play, you'll see that my head is moving once again. And you'll notice in some cases it's rolling, in some cases it's not. In translation, it's just moving along. It's not being forced to roll, but in both velocity, because we're utilizing the rigid body, in both velocity and force, our head will actually roll. Now, with velocity, you'll note that the second I let go of the button, the head stops rolling. All right, let go of the button, the head stops rolling. Okay, you'll notice that. However, you'll note that in the case of my force, when I hit play, as I hit the button, my head doesn't stop rolling right away. If I hold the button down, my head keeps rolling. I've let go a long time ago. That head is continuing to roll. Hold the button, go the other way. I'm going to let go. I'm not holding the button at all. It's still rolling. The reason why is because of our rigid body settings. If you are utilizing this type of movement, and maybe you have some kind of drift or something like that in your character, you are going to have that with the force, right? The force continues to be applied. And this object has to slow down on its own. If you're not applying a force in the opposite direction, it's not going to stop instantly, not like the velocity. In the case of velocity, when we let go of the button, we are setting our velocity to a value of 0, so it instantly stops. In the case of force, we've applied a force. We're no longer applying a force, but it still has that momentum, and it's going to continue to roll until it is able to stop. The way to stop it when you're utilizing force is to adjust the values in your rigid body, particularly that of your linear drag in the case of the X. So if I give this a value, let's say 10 in my linear drag, and I'm just making that number up, when I hit play now, and I hold my button down, you can see that I'm holding it. It's going really slowly because the linear drag is slowing it down over and over again. All right, but when I let go, it stops moving. Let's see what happens if I change that to a value of 1. All right, I'm going to hit return here, and let's play it one more time. So I'm going to hit the left button, and you can see I start to roll, and I let go, and I slow down a little bit slowly. All right, I let go, and I slow down a little bit slowly. All right, so I've still got some drag there. The key is going to be to find a value of your linear drag that gives you the movement you want. All right, and your linear drag can be set through code as well. If you want to have like a kind of like a lerp into your stop, you could do so with that. All right, so let's say I put a value here of, I don't know, a 5 to see if that's more what I'm looking for. And I'm going to change the value of my speed inside of this, my move distance, to a value of, let's say, 10. What is that going to do? So when you use this kind of movement, you're going to have to really go through and adjust. There we go. See, that stops kind of quickly. All right, so I've got a faster ramp up in speed, and I have a little bit of drift, and my object slows down. All right, so if you're using this type of movement, you're going to have to really figure out the values you want to put in here in order to get the appropriate movement of your character, all right? You're really looking at the feeling that you're getting. You want to make sure that your controls are responsive and they're giving you the mechanics you want. Do you want that drift? Do you want it to stop instantly? Is it more of an arcade-style game? What are you looking for? All right, that doesn't feel too bad, actually. So the value of 10 and 5 work pretty darn good. I'm able to reverse directions pretty quickly. All right, with only a little tiny bit of drift. That doesn't feel so bad. But it's all about playing with those numbers. In fact, maybe I want to boost one up a little higher or a little lower. Maybe I want a move distance of 20, so it's going a lot more, but I want it to slow down relatively quickly as well, so I'm going to change my linear drag to, let's say, 15. I don't know what this is going to do, right? I'm just playing with this to see what it's going to do. You have to do the same thing with your particular controllers. So you can see how much slide. Look how much slide I had there. Oh, I reversed directions, and it's still sliding. So I'm getting kind of that sliding action. All right, with that slowdown. So that's kind of neat as well. And again, guys, like I said, it's up to you guys to play around with numbers. Once you've decided what your movement is going to be like, play with those numbers and see what you want. All right, guys, that's it. I hope that was helpful. We're already at the point now we are moving our character around. You can start to make games right now just with what you have. Just with what you have now, you can be making yourself some pretty cool games. All right, guys, I hope you enjoyed it. If you did, let me know down below with a thumbs up. And if you didn't, a thumbs down is perfectly fine. I'm doing this for my students. My students are doing a great job. I'm really proud of them. I hope they're watching these videos because this is for you guys. You guys out there on YouTube, I hope you are enjoying it as well. If you have any questions about Centennial, please let me know. The program itself is amazing. Come on in, come and meet me, get an education, get into games. All right, guys? Thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.